Grignard reagent form, what are the reaction mechanism of Grignard, and what are the exceptional cases with solved examples of reaction mechanism of Grignard reagent. So let's start with the formation of Grignard reagent and the structure of Grignard reagent. To prepare Grignard reagent, what we required, one is RBr, and this is treated with magnesium in presence of ether. You can able to take any non-polar solvent, but ether is useful because it traps the Grignard reagent. Now the reaction mechanism starts with magnesium converts to Mg2 plus with the formation of 2 electrons, and RBr in presence of 2 electron is converted to R plus and Br minus. This R plus accept 2 electron to give you R minus. Now this R minus, there is a Mg2 plus and there is a Br minus in ether, and all of you know that ether are non-polar solvent. So this R minus to stabilize form a bond with the magnesium, and magnesium plus 1 form a bond with R. So it is converted to RMgBr. The very important thing is between R, this is, let's say alkyl group is R and magnesium, this bond is polar covalent bond and electron are towards R minus, whereas the bond between magnesium and bromine is purely ionic bond. In Grignard reagent, RMgBr, this is polar covalent and electron are towards carbon. That means it is a very good source of nucleophile, which is R minus. So Grignard can able to give you R minus, which is a very good nucleophile. So why Grignard is so popular? The reason is RMgBr is a good source of R minus, which act as a very good nucleophile. The second thing, why we have taken ether. See, as I have explained, the reaction of Grignard, the structure of Grignard is RMgBr. When you take this in the etheric solution, ether consists of lone pair of electron. So two molecules of ether trap a Grignard reagent and increase its stability. So because of this, we take non-polar solvent ether. We can able to prepare Grignard in CCl4 as well as in the benzene, but preparing Grignard in presence of ether will give additional stability to our Grignard reagent. So we are generally taking ether as a solvent. Let's see what are the reaction mechanism of Grignard reagent. Grignard reagent reaction mechanism are classified into 4 different parts. First is reaction with active hydrogen, second is reaction with nucleophilic addition, third is reaction with nucleophilic followed by substitution, fourth is nucleophilic substitution. If you are talking about the rate of reaction, the highest rate will be for first, then second, then third, then fourth. That means Grignard reagent react very fast with the polar or active hydrogen, then second nucleophilic addition, third nucleophilic addition followed by substitution, fourth nucleophilic substitution. One by one I am going to explain all the mechanism, but always remember the order. That means if a molecule consists of active hydrogen as well as nucleophilic site, and in question it is given that there is only one Grignard, you always react with polar hydrogen at first. Reactivity with active or polar hydrogen, what does it mean? First of all, Grignard reagent consists of RMgBr. Now, if Grignard reagent is treated with water in presence of H plus, what happened? It is a very good source of R minus. This R minus remove one polar hydrogen will give you RH and MgOHBr. Now the point is, if it consists of polar hydrogen, why we have added H plus? Actually what happened, MgOHBr is a gelatinous precipitate. To dissolve this gelatinous precipitate, this H plus is added. If you are unable to add H plus, this gelatinous precipitate prevent or stop the reaction. Now this H plus react with gelatinous precipitate and it will give you Mg2 plus water and Br minus. Because of this, H plus is added. Now active hydrogen means if you take Grignard reagent RMgBr and react with this molecule which consists of large number of active hydrogen. For example, let us take a molecule like this. Now this molecule is treated with RMgR. this hydrogen is acidic because of sp hybridized. This hydrogen is acidic, this hydrogen is acidic. So one molecule of this can react with 3 molecule of RMgBr to give you 3RH. So this is a very good method to identify whether the particular given molecule consists of how many number of polar hydrogen. This method is also known as Very-Wittnoff's method to identify the polar or active hydrogen. So one molecule of this react with 3 molecule of Grignard to give you 3 molecule of alkane. So this is all about active hydrogen, the most reactive Grignard. Grignard react very fast with polar or active hydrogen. Now let us consider the second part, nucleophilic addition. Nucleophilic addition undergo with the ketone as well as aldehyde, and the mechanism for aldehyde and ketone are identical. This is a Grignard reagent which we have added in the ketone. Now the Grignard reagent attack to this carbon because it consists of partial positive charge. So CH3 CH2Br MgBr approach to this carbon, and both the electron are accepted by this oxygen, and MgBr attack to this oxygen. So you will get a adduct like this, O minus attached with MgBr and ethylic group at this. When acidic water is treated, you will get tertiary alcohol. Similarly, for aldehyde, if I take cyclohexyl magnesium bromide, you will get this molecule. Now, talking about the rate of reaction between aldehyde and ketone, you can able to see that ketones are more sterically hindered, so it is difficult to add Grignard. So the rate of reaction are always higher in aldehyde as compared to ketone. But if a molecule consists of polar or active hydrogen, let's say we have alcohol, second molecule is we have aldehyde, third molecule is we have ketone. So this is first, this is second, this is third. The rate order will be 1 greater than 2 greater than 3. Although I have written this mechanism at this point of view, but if you go in detail, the Grignard reaction mechanism involves 2 molecule of carbonyl compound, 2 molecule of Grignard forming a 6-member cyclic chain, and the reaction proceed. But in general, we follow this mechanism. Moving to the third part, nucleophilic addition followed by substitution. This take place in presence of ester, amides, or acyl chloride. What happened and what is the basic difference between this as well as compared to the aldehyde and ketone? So in aldehyde and ketone, R group attack to this carbonyl. Similar method is there. R group attack to this carbon. Oxygen get negative charge which is attached with MgBr. Now what happened in aldehyde and ketone? This upon hydrolysis attack with the H3O plus. But in this case, what happened? I have skipped one step. In the very first step, you will get OMgBr. This is the methyl group, and there is a O ethyl group. Now, the plus R effect of this remove this as a leaving group. So, I have written this nucleophilic addition followed by substitution. See, this first step is addition, and the second step is plus R effect. Removing this is one kind of substitution. So, you will get R C double bond O CH3 with the elimination of this group as MgBr. Now one more molecule of CH3MgCl will react with this carbonyl to give you this molecule. So you can able to see it consists of 2 methyl group which are blue colored. That means there are 2 Grignard involved with this molecule. So at first Grignard attack to this carbon, plus R effect of this, remove the leaving group, and the second Grignard attack to again this one to give you 2 alkyl. After hydrolysis, you can able to get secondary alcohol. Same mechanism with the cyclic compound. But if you are talking about the rate of reaction, again, polar, there is alcohol is faster than aldehyde, which I have already explained in my last point. Then it is more reactive than ketone, and it is less reactive than esters. So these are the fourth in the sequence of reactivity. Nucleophilic substitution. Nucleophilic substitution is one kind of SN2 reaction in which we trade Grignard RMgBr with RBr. Now this R attack to this carbon, this bromine will leave from this. So you will get RR. So what happened? We are going to break a sigma bond with the formation of new sigma bond. Therefore, the rate of nucleophilic substitution is very less. That means, if I ask you, RMgBr reaction with formaldehyde, with aldehyde, with ketone, with ester, and RBr, the highest rate will be one more alcohol. So the highest rate will be for polar or active hydrogen, then for aldehyde, then for formaldehyde, then for aldehyde, then for ketone, then for ester, and the least reactive is 6 because we are going to break sigma bond to form RR. So Grignard reagent least reactive with nucleophilic substitution type of reaction. Another example of a cyclic compound, this is also nucleophilic substitution in which Grignard reagent attack to less sterically hindered carbon. So this carbon will attack to this carbon, both the electron accepted by oxygen. So oxygen negative, which is attached with the MgBr. Exceptional behavior of Grignard reagent. So see, the first exceptional behavior is, let's say we have a carbonyl compound consists of very bulky group like this. So you can able to see that this carbonyl compound consists of two bulky groups. So it is very difficult to introduce a nucleophile at this carbonyl compound. As I have already explained, Grignard reagent actual mechanism starts with the formation of a cyclic intermediate in which two molecule of Grignard and two molecule of carbonyl compound form a cyclic compound. So it is a sterically hindered group. So despite of attack of this carbon to this carbonyl compound, what happened? The alpha hydrogen, this is a negative charge, both the electron are come to this position, it remove the H minus, this H minus will approach to this. So this is the exceptional behavior because there is no carbon-carbon bond formation take place, and it will give you alcohol and alkene. So this is the first exceptional case because of sterically hindered carbon. Now, if you want to convert molecule with two primary alcohol, it is possible with the formation of compound having one lithium. So if you take Li group, you will get a alcohol which you want to prepare. So this is the first exceptional case. In the second exceptional case, let us take the example of 1,4 addition. So 1,4 addition, what happened? If you take Grignard reagent, the oxygen atom, magnesium is approached by the oxygen. So why I am saying exceptional? Because see, this is the case when we take Grignard to this molecule, and what we will expect is formation of compound like this. Now, when magnesium approach to this oxygen, both the electron are come to this position and R3 approach attack to this. So if you count from first, not according to IUPAC, 1, 2, 3, 4. So first and fourth position, Grignard addition take place. So this is what we call 1,4 addition. So any carbonyl compound having alpha unsaturation undergo 1,4 addition, and you are unable to add nucleophile at this position, but although some byproduct consists of nucleophile at this position. So this is the second exceptional case of Grignard reagent. Moving to third exceptional case. Let's say we have a carbonyl compound and it consists of C double bond OH and OH, and we are preparing alcohol by adding Grignard. So it is not possible to add Grignard to this carbon because it consists of polar hydrogen. So when you take Grignard reagent with such carbonyl compound which consists of polar or active hydrogen, the acid-base reaction takes place at first. Stereochemistry of Grignard. See, carbonyl compound are the triangular planar structure. The nucleophile can attack from above or below the plane. That means enantiomers will form. For example, let us take an example of ethanol. And as I have explained in this structure, ethanol is a triangular planar, and I have treated this with RMgBr. Now this R can attack above or below the plane, this nucleophile above or below the plane. So if nucleophile attack above or below the plane, can I get the two possibility of formation of this product after hydrolysis is the hydrogen at below the plane, whereas the alkyl group which is approaching is above the plane, plus the hydroxy group or the alkyl group is below the plane and the hydrogen is above the plane. So these are the two mirror images of each other. So if addition of Grignard generate chiral carbon, you will get R plus S isomer. So complete racemization take place in the addition of Grignard reagent. I've tried to mention all the reaction of Grignard with different reagent, starting from cyclic compound, formaldehydes, aldehydes, ketone, imines, carbon dioxide give you carboxylic acid, O-methyl substituted amides, acyl chlorides, and esters. So you can able to see and take the screenshot. In this case, I have taken almost all possible functional group reaction with Grignard reagent and what are the products which are formed. You can able to write down the mechanism of each and every reaction. Moving to few examples of Grignard reagent, questions of Grignard reagent. See, ethyl magnesium bromide in presence of tetrahydrofuran NH3O plus. So you can able to see that there is a carbonyl compound, there is a polar hydrogen, and polar hydrogen are more reactive than carbonyl compound. That means the correct option is third, in which polar hydrogen is eliminated. Moving to the second question. This is a protecting group, protect this aldehyde. So this is a protecting group protected, and I have to react this magnesium and THF. So what should I add to get a product like this? See, this is a bromine. When magnesium is treated, this is converted to Grignard. So in after adding first reagent, I will get MgBr, and this is a protected group. So I have to form this molecule. So can I treat this molecule as formaldehyde? So this will attack to this will CH2OH, you will get this. So the correct answer of second is formaldehyde. Moving to next question. Always remember that carbonyl compound consists of partial plus. Higher the partial plus, stronger will be the rate of reaction. OMe, the plus R effect. Plus R effect generate negative charge at this carbon, reduce the partial positive. So the meta para position partial plus is lower. So A will be more reactive, although it is aldehyde. But if aldehyde is the para position, then the C will be the more reactive because the partial plus predominate over the steric hindrance. What will the major product of the following reaction? So this is the last question of Grignard reagent. So the cyclic ether. Generally, cyclic ether are unreactive. Generally, ethers are unreactive with Grignard, but cyclic ether are highly unstable, 3-member and 4-member ring. So such molecule can easily react with Grignard. So this is CH3 minus approaches to this carbon. Both the electron are accepted by this oxygen. So if this ring will open, it will give you OMgBr with the formation of CH3. After acidic hydrolysis, you will get OH and ethylic group. So B will be the correct answer. I hope you have understood Grignard reagent very well. Solve more questions after this theoretical class so that you can have better understanding in the concept of Grignard. Thank you.